This is a follow-up video to a three-parter Lambda, Angular, Mongo stack that I've done. I wanted to sort of do a proof of concept of serverless applications. So I started with just a very simple, not a hello world, but a to-do application. And it's just very basic, right? A lot of this stuff that you'll see forms the basic functionality of your application. This is web-based. You could create a mobile-based application that does similar things, but essentially you have a login page. When you have a to-do app, you want to access your data as yourself and pull in data based on things that you've entered. So a basic application is going to have some authentication and authorization. So go here and log in, and it'll bring you to a list of the to-do items that you've created in the past. So the very first thing obviously you're going to do is create a to-do item. So let's do demo test 2000. Hit create. The other thing is obviously list the to-do items, which we've sort of done here. Then you can also edit your items, load or get that one individual item, load it, and then make some modification to it, and hit save. And hopefully it saves in the system, and you get the updated item in the list. And then you can also go in and delete an item. So if I click delete here, it should delete the item and then return the remaining things. So this is a very basic function, but there's not too many other, most basic apps are going to do this. It's a basic CRUD and search. Create an object, update it, delete it, list it, and search for it. And obviously you have to have some sort of user context, and you have the authentication and authorization. So what I did was create some structure here within AWS, use some components in it, created some code for Lambda and Angular. So this is the code I created is out there. It's under Apollo Rocks, under Bitbucket, to do AWS Lambda. So a lot of the stuff I'm referencing code-wise you can find. The configuration is a little bit of a setup, but download that and you can play with it. You can run. You should be able to run the code locally in the Angular app using ngserve, and then let's see. Will it work? Will it work? I think if you're running Lambda, it may not exactly work that way. So let's skip that for now. I'm going to edit that part of it, obviously. But let's view the architecture a little bit. So here's the architecture. It's all AWS except for the Mongo piece, because Mongo is a little bit, it's free and it's easier to sort of interact with. I'm a little bit more familiar with it. Not that much more familiar, but have a ready knowledge of that. So let's look at the architecture. We have Route 53, which is going to direct my website or route calls to my website via this, which points to an S3 bucket that hosts my to-do application. Is going to serve up the static files that are going to be built and then deployed to this bucket under this folder. And then the web browser is going to receive my client packages or modules and run that client on the web browser, and that Angular client is going to call a gateway API, which is going to map to a resource method, which is going to get mapped to a Lambda function. So Angular client calls a web API resource method, and that calls a Lambda function, which is going to call a MongoDB or call APIs against a MongoDB to get data, to update, to delete, to list. Some of the other things that sort of in here is Cognito, which is a it's a user pool where users can sort of add, where you can programmatically add new users, authenticate against that particular framework, and also authorize. You can secure your gateway methods using Cognito, and I'll sort of show how that's done. And then for this, I just did traditional REST, where every, you have a resource like to do items, and you do get methods or method calls, HTTP method calls, post, delete, put, and then what I did was I created a Lambda function for each one. But you don't necessarily have to follow that pattern. You probably, for standard interfaces, you probably want separate methods to operate against your resource that you're sort of managing, to do items, user items, schedule items, etc. You probably want that, but to map it one-to-one to a Lambda, you don't necessarily have to do that, but it's a strategy. For a small app, I think it's okay to do this. For bigger apps that have a lot more resources and a lot of different business objects, you have to rethink how many of these lambdas you want to put out there and manage, and what's the best way to do that. Let's see, so some of the other lambdas in here are the sign-in lambdas, and the sign-in just lets you either register or log in with existing credentials and get some sort of token back. The to-do pre-sign up is more of, it's a trigger when the sign-in Lambda calls Cognito and says, hey, I have this new user, sign him up. This trigger just does an auto-confirm on that particular user, so you don't have, there's not a manual step that someone has to go through and check off a box to say, hey, this user is valid. For this one, that's okay. For this demo, it's okay to have an automatic confirm, just to sort of keep things flowing. Maybe for other apps too, you just want people to sign up and keep track of who they are, and the user context, and sort of help out manage their user preferences. But this is architecture. Route 53 to an S3 bucket, that's requests are sort of mapped to that. Angular client, that S3 serves up, runs on the browser, invokes your gateway API, which invokes Lambda function, which invokes some functionality against MongoDB. Cognito as your authentication authorization secures most of your Lambda. So it's pretty straightforward. The architecture, there's some implementation and configuration setup that you have to do. So the backbone of your application is going to be your compute or your active components. And those are a lot of the work that you need done is going to be done on the Lambda side, which has your get, add, delete, update. So those are the more active and probably the more important pieces. The GUI can be Angular, it could be React, it could be Ionic. For if you want to run mobile apps, it could be Unity, it could be Xcode that runs on mobile. It could even be Java for Android systems. But the more important things, I think, is happening in the back end, and how that gets mapped. How HTTP calls get mapped to it is important, but this is the ones that are actually the units, the components that are actually doing work. So let's take a look at how we set that up. So if you go to services and click on, let's see, Lambda, you'll get your list of Lambda functions, and there's other tutorials out there that sort of show you how to do that. But we'll take a look at the to-do. Let's see, to-do get. That's the individual item. let's see. Let's take a look at to do get items. So it's a typical Lambda function. It's Node.js is if you download the source code, it's running. It's JavaScript. App handler. If you have an app.js as your primary entry into your code, you want to set this to app handler. But it's sort of generic. I made it a little bit generic so you can reuse the same archive zip file module to run against multiple lambdas. And what I did was, this is generic code, the app.js code. I went and imported other functions from other files. So I've got a bunch of handlers: add to do JS, delete to do JS, get to do. But this app.js is primarily routing requests from the API gateways to these other functions. It's pretty straightforward here. We're doing, it's going to look at the action environment variable to know which of these real handler classes to call. So if you look at the handler classes, if you've done Lambda before, this is very similar. It does modules, exports. You've got the event, context, callback, and we've got several of these. And this is, for this method of publishing things, is just to make it easy to have one archive file instead of trying to create multiple archive files that go to multiple lambdas. It's just one archive file, and just we configure each lambda to change their direct or path in the code. So here's the action. Any calls to this lambda direct, it's a list to do. So this lambda is going to, or this app.js code is going to look at the action variable and says, oh, I've got this route map. This list to do goes against the get to do list function, which is defined over here, and it just does the get to do list. So I did create a bunch of Lambda functions, but I've sort of made the deployment a little bit easier. So you have to do add, to do delete, etc. So this is one-to-one matching with my resource, which is the to-do resource that maps to get, post, update, delete, etc. But let's take a look at the code real quick, and we'll look at the API gateway mapping and creation. So let's see. Here's the Lambda. Just for the sake of just the deployment, just how to get it out there. If you look at package JSON, there is the zip archive, or the zip it script. So you zip up into archive.zip everything in node modules and everything in handlers. So those were the 6 or 7 different files that I showed in the Lambda function configuration there. And then you're also zipping up app.js. I don't think you need this package JSON, but I put it in there anyway. I'm going to say you don't need it. And then this will just create an archive. So we can find, where's my finder? Let's take a look at, where are these files? Good question. Is it under documents, development, under AWS? Got it. So if you look at it, it's going to create this archive zip file in order to deploy, or to package up all the source file that I need to put into Lambda. Now you can manually go in here and select a zip file to upload, but that is not probably the most efficient way to upload your source code, especially if you've got 5 or 6 different lambdas to upload. So AWS, the command line interface, has a better way to sort of fix that or make that a bit more efficient. So I have this published bash script that I run. So I run the npm run zipit, which packages up all of my source file into a zip file, and then you can call AWS Lambda, and then it just says update code. Give it the function name that you created in the AWS console, and zip and tell it what zip file to upload, which it has to follow this file B archive zip format. So once you've initially created your Lambda, and if you do it manually, hopefully you only have to do it once, but you could probably use some other framework in order to create the different components in AWS a little bit more easily. Terraform will give you that capability, and I'll do another video on how to sort of, initially create your infrastructure, quote unquote, within AWS. And then there's probably a better way to deploy this. Code deploy in AWS could probably solve this a little bit better, but deployment of code is probably as simple as this if you're just running it by yourself. If you want it to be automated, obviously you want to use code deploy in order to make that better. But it's a one-man show kind of deal. But once you start getting into bigger teams, you definitely want to utilize, take advantage of what's out there. All right, so I got all my Lambda function. All that code can go up there pretty quickly and pretty easily. So again, it's just for this strategy of how to sort of use one library, one module to service your application. I use this environmental variable to sort of help direct the code that handles the request. All right, so that is the Lambda part of this. We've got 4, 5, 6 different Lambdas that does sign up, CRUD, and some registration functionality. A little bit about the code. The code is pretty straightforward. As I said before, app.js just goes in and checks the environment variable. It does this update event loop ignore. Now I've talked about this previously, but it just makes sure that the Lambda doesn't get hung. In the AWS version of this, it's going to invoke this callback waits for empty event loop equals to false. So set your environment variable to that so it doesn't hang and gives you an error because of this issue, this messaging issue. But once here we create a route map that says, hey, if the action is a particular string, then return this, map it to this particular function. So this get to do list is pretty straightforward. MongoDB, this is what Lambda functions look like. If you sort of create one out of the box, you got a connection string, collection name, and this one has some fancy stuff going on. It looks at the query string, and all it does is if there's an ID, then if there's an ID in the query string parameter, then it is going to get the individual item, which is going to be a different data that's returned. Otherwise, it's just, for now, it's not user contextual, so it's not user specific data. It's just getting everything. So anybody who signs up and puts in to do items, it's going to get it. That can be easily fixable. You can look at the context and see who the user is invoking, and I don't know how to, I don't remember, or I haven't connected the context to, you can get the, what is it called, the authentication parameter of the request and use that to sort of identify who the user is. The Cognito API gateway setup might already do that, but I don't know that piece of it yet. But so you go in here and you check to see if the ID is not null. If it is not null, then you return the individual item. Otherwise, you're going to connect to Mongo. When the connection is complete, it's going to go in and sort of create this query, and this is where you could sort of make it user specific, but for now it just returns everything, and it processes through each item and adds it to this document collection. Somewhere we define a documents, there we go, a documents collection there, and then we just push the document to the documents collection. And then this is what's called every time every time the API or the Mongo library gets a document, it calls this method, and we just keep adding the documents until we get a null, and that signals to the code that we're done getting documents, or there's no more documents. And then we send documents, and we do this callback. And then this one there's probably a better way to do this within the context of the API gateway and the mapping from Lambda to the gateway response, but here we do this access control allow origin because we're calling this API from leapingbots.com/todo. So it's a cross script call to our API. So I don't want to do this work here, but I know this works. It can probably be done elsewhere, but I need to do this in order to make the calls from Angular client from leapingbots.com work. So that's a little bit of the code, and a lot of the code is very similar. We're doing insert for add, and we're just returning error messages. We're not returning the actual object. The delete does this delete one, and then the individual get to do it does this find one, and then returns. Actually, it still returns it as collection, I believe. Body that otherwise body is items. Yep, there's a new record, and it's not really a new record, but it's a existing record. And then update to do is going to do a similar thing. Find the to do record using the ID and set that item, this to do object, to whatever that's mapped to, or whatever that ID sort of finds. All right, so that's a little bit of how the Lambda is set up and the code behind it, and just an easy poor man's version of a deploy. You just zip it, run AWS Lambda update function, and it's deployed out to Lambda. All right, so the next component of this is we have a Lambda function. It could be invoked from Java, and you could call a Lambda function directly, but for the behavior of that is sometimes a little bit flaky depending on what sort of ecosystem you are. I found in Unity 3D I had some issues with a Lambda invoking any AWS library directly because it was doing some linking sort of translation thing. I don't even remember, but I found like exposing your functionality via web API or REST service as REST services is a lot more reliable, and that communication is a lot easy. So you set up your web API, your REST services using this API gateway, and you can create an API that has a bunch of resources. And this particular to-do API has got this authenticate resource, which manages login and registration. It's really just one thing that it does, which it does this post, and it does this method request, and it does this Lambda integration, which calls this Lambda to do sign up. And then this is sort of default stuff here, but it goes through and just returns the response pretty much as is from whatever is returned in that context call, or not context, but the response call from Lambda. And then I've set up this other resource called to do items, and you've got this get, which can I've sort of changed this up a little bit from other request type. This post, let me go back to authenticate. This is just a straight pass through. If you look at the integration request, you got a Lambda function that this is sort of how it comes out of the box. You select the region that your Lambda resides and you give it the Lambda. But for the to do items get, I have to do some other fancy stuff like the cross-site reference I had to do, and I did what did we do? I did this use Lambda proxy integration, which behaves a little bit differently. Things are not passed through as well, and you can sort of access the query string that that is made, or that comes from the URL from the request that's made from the client. So it's a little bit different. I think delete is sort of similar too. I did Lambda proxy, same thing with, did I do that with post? I don't remember. So this one's straight through because nothing fancy going on there. And same thing with the put. So it's a pretty easy setup to sort of direct your API resource method to map to your get items. See, what else is special about this? I can secure these methods that are on my resource for my API using AWS Cognito. And that's just a user pool that has authentication that you can apply authorization to. But in order to do that, you have to set up these authorizers. Obviously, you have to create your Cognito user pool, but you have these authorizers, and you can add Cognito as an authorizer for your to-do API. And then once you've sort of hooked up your, created your resource and your methods on that resource, you can go in here and select Cognito as one of your authorizers. And the authorizer just means that don't let anybody access this method on your resource unless they're authenticated against whatever is doing authorization. In this case, it's Cognito. Notice like authenticate doesn't have an authorization an authorizer, because this is how you're logging in. You know, people who are not logged in has to be able to log in, so you can't secure, you shouldn't secure this particular method on this resource that does authentication. But this returns a security token that you use to in your request to your other methods. You pass in the authorization header, and you can set that up. Can I set it up here? Yes. So my token source in the request should pass in the authorization header in that particular HTTP request, in the header of the HTTP request. So that's how you set up your API gateway. There's probably a Terraform way to set all this up, so you don't have to do it manually. But if it's a small enough application, you can set this up manually initially, and then you take these actions. You have to deploy these APIs, and then those are how you access these methods via HTTP. So you create a prod stage, and then these are all of your methods, and this is the URL to get to those particular methods. Obviously, you have to set your HTTP to the right method call, but that's how it's set up. Pretty straightforward. All right, so I just wanted to review where we are. So we talked a little bit about how to initially create your Lambda functions and how you can deploy Lambda to AWS using the AWS command line interface, and then I showed a little bit of the source code to access the MongoDB stuff. And then I also showed how to set up your to-do API gateway with Cognito in order to route the request, create an API with resources and methods, and how to route those into your Lambda functions. Next, let's take a look at Cognito real quick. I think if you've done it before, it's pretty straightforward, but Cognito, if you go in and let me go here and do, oh, this is Cognito. So if you go to AWS and go to services and type in Cognito, you'll get that. And then you can create your user pool. And if you look at some other videos that I've done on how to create a Cognito user pool, it's pretty straightforward. To do user pool, it's got this information. Once you've set it all up, you can assign this particular authorizer in your, where is it, API gateway API, and then tell your methods to use, where are we at? Not that one, but resources. Tell your methods to use your Cognito user pool as an authorizer for that method. So that will sort of secure your API functions or your API methods. All right, so that's Cognito. All right, so what you have is where's the starting point? Is it main TS? I believe it's main TS. You've got an app module that resides in here. It's going to be bootstrapped. What's bootstrap? Yep, the app module is, or the app component is bootstrapped within app module. So app component, here's the HTML for it. You've got some, do we have navigation? Yep, you've got some some routing going on. We created these router links. And if you look at the app module, it's going to pull in everything it needs. You got a login page, to do page component, login service, to do service, to do create component. And here we're going to declare app components. These are my different components that I've created. And Angular will understand sort of the, what is it called? Is it descriptor? Let's see what it's called. Go to my components, login page, and in the declaration, it's called a selector. So when it runs into this app login page in the HTML, it sort of knows what component to create when it sees that. You won't see it here, but this is setting up sort of the router stuff. The router outlet says I'm going to render these components that's sort of link back to this particular declaration, this router link. So this first one has home, create, login, and on our application, right, it has home, create, login. These are all router links. When you click on that, it's going to display the content of, well, let's see, router link, create, active. The app module sort of knows where that router stuff is defined. So this app routes, right, when it sees, where is it? I need my HTML here. When it sees this route / to-do list / create / login, this route map for these routes, say / to-do list, invoke this component / login, render this component, create, render that component. So, and then render it inside of this guy. So router link is just a way to specify a path, and then Angular figures out which component is appropriate or is the right component to create for that particular path. All right, so what I want to go over here is, let's take a look at the login page component. The doing some fancy stuff on init. If it's not authenticated, set the login to true. If it's authenticated, check to see if it's authenticated. So I created this login service to sort of manage whether the user is logged in or not. And then if we need to log in, go in and provide a login functionality. So this will do when the user, let's take a look at the HTML page. We got username. I incorporated Bootstrap in here. I'm not going to go over that too much, but the main thing is just trying to get this architecture sort of in place. But when you click the button, login, then it's going to call this onLogin function for the component. And onLogin just calls a service, and this service was injected into this component using sort of this expression, declare private login service. It's going to, if you reference this.login service, it's going to have this instance of the login service. And then once, so when we log in, we call the service login, give it the user password and whoa, haha, that's a bug. This should be username and user password, so good catch. So I've been doing Apollo 123, so it's all been Apollo 123, Apollo 123. So let's go back to this login page, component HTML. So our username should be bound to username, and that should be bound to user password. All right, let's go back to here. But we're using observable pattern here. It's doing a subscribe, and I'm just calling this login success or on login success. If it's successful, if there's an error, then it's probably a username password is incorrect. And then we're using bind this because it doesn't do well when I sort of invoke a function outside of outside of a certain expression. I don't remember the dynamic declaration of functions that this works fine, but use bind this to make sure that when this subscribe completes and Angular calls this function, that this is referencing this, which is referencing the instance of this component. So let's take a look at login, and that's where we're making the API call. So login, you can have a URL. This is not the best way to obviously organize this code. You don't want to put like hard-coded strings. Probably need at least the root of this API URL somewhere else. I guess it's okay to have prod / or not even prod, but authenticate as a string within here. But probably the root of this should go somewhere else. Anyway. So login, it just invokes an HTTP post. It's going to return stuff. Let's see, post map response. This is going to return something back from our authenticate API gateway, but it's going to return the token for this username and password. And we're going to use that in our subsequent calls. And then just as a helpful, we're storing it in local storage. I don't know if this is the best way to do it, but for now I think it's okay. But local storage means it's stored in the browser but not as cookies. It's an area for this particular user, but we're saving our token into this local storage. So when we go in, let's take a look at one of the pages, which is the to-do page, which is going to have the list of to-do items. We determine if it's logged in. Again, the login service is injected into this component, and we can check to see if the token exists locally or not. It's probably not the best way because it's going to expire at some point, and you don't have a this doesn't have a mechanism to check to see what the expiration is or whether to re-log in or not. But for now, it's good enough. It works. So we're going to go in when it's first initialized. we're going to invoke on refresh, which can be invoked by the button as well. So on refresh, it's going to invoke this to-do service, get items, and I think to-do service is aware of the tokens. Let's see, go to definition. To-do service is using the login service. So this same login service is instantiated at the module level. So any children of the module is going to use the same login service unless you sort of go in here and do a different declaration in your component level and do some other. You can declare your own, request your own instance of the login service, but we're using the one. So what it's going to do, the most important part here is when it creates these requests, it's going to set the authorization set the authorization header using the authentication token that we got back from our login service. And then it does get items, get URL, map, join, and return it's getting the result back and converting it to JSON and then returning that to whatever's calling that service, that method on that service. So on refresh, it does get items, subscribe. It's going to get item success, and the result is already converted to JSON. So we get the items from our web API or API gateway API Lambda call and update this.items, and it just this.items, we just go through and do an ng4, iterate through the item of items and map the different fields in there. And we create this router link if we wanted to edit the individual items. So that's the basics of the Angular client. There's a lot of Bootstrap, there's a lot of other things in there, and it's a lot to go through, but the basics is you've got an Angular client that's going to log in, you get a token back, and then you're going to use that token in subsequent calls, because all of your web APIs that are not this authenticate REST service is secured using our Cognito user pool. All right, so one of the other pieces that we need is we need to serve up our client files, and for that we need somewhere to store those files. But before we do that, let's take a look at how we could possibly deploy. So if you look at package.json on that Angular to-do project, package.json, we have the typical ng build, and this -- base href tells us what the root of the that deployed package is. If we didn't put this /todo, then it would try to go to bleepingbots.com. If we leave, the routing will try to go to bleepingbots.com as the home page, and we don't want that. We want bleepingbots.com /todo when we hit the home page. Otherwise, it'll just mess it up, and you couldn't deploy more than one Angular app if you didn't set the base ref. So this helps out the routing, and then you have to do this --deploy -url /do as well. So the ng build will get you local build of Webpack all of your different source files and put them in this file. It'll also Webpack all of your node modules that you need to run your Angular client app. But in order to get it to or you want an easy way to take all of your distribution files and sort of move it up there, you can go and manually copy that whole folder into S3, and here's the S3, by the way. You can create an S3, map it to a domain, and use Route 53 for that. But once you go into your Bitbucket, it's just a folder structure. You create folders. Here's my to-do folder, and then you can copy and paste. You can upload those files. Drag it from Finder. Let's see, where is it? To do. Take your dist files that was generated by your ng build and just upload it through here. Very manual. Works okay, I guess, but you don't want to be doing that all the time. So you can create another script and do an S3 push and do AWS. It's another client or command line interface for it, and it's AWS, but you can invoke an S3, and this does a copy this folder dist /, which is everything under there, and then the resource S3, your name of your bucket, and the folder, and -- recursive means get all files, get all folders underneath that. So for deployment, it's pretty straightforward. For continuous integration, again, you have to set that up using code deploy. But if you have a small app, the really quick way to just put that stuff out there. So that's S3. Integrate an S3 bucket. Go to S3. Create bucket. Boom, you're done. Right? Enter your, if you're mapping it to a particular domain name, you want to enter your domain name, which is, for me, is Bleeping Bots. And then obviously pick your regions, etc., and set properties. Probably don't want to make it public. Shh. Okay, let's see what else we have. And that's pretty much it on sort of deploying your Angular app out there. So now we have our Bleeping Bots, our S3 that has our Angular static files that calls our to-do API gateway, API resource and methods that's secured by Cognito, that calls our Lambda function, and that calls MongoDB. So the only other thing is really this Route 53, which is, again, it's pretty straightforward. Go to Route 53 management. I'm probably going to sort of mask this information. I don't know how much of this is sort of secure or not, or should be secured or not. But you go in and you can create hosted zones, or you can create hosted zones and add a domain. And then in here, you can add an alias that maps your S3 to this particular domain name. So that is pretty straightforward as well. Let me click on this, and you can see sort of all the information here. The type is alias IPv4 address, and then alias target is, I think this is the same regardless of the name of your site. And then I don't remember where that came from, but there's tutorials out there on how to set up S3, or how to route a domain name to an S3 Bitbucket bucket. Not Bitbucket, an S3 bucket, sorry. And I think that sort of wraps it up. You've got your Route 53 that routes domain traffic to your S3, which serves up the static files that you need to run your Angular client on your web browser. And then it goes through and calls API gateway, which is secured by Cognito. These methods are mapped to or invoke Lambda functions. So Lambda functions invoke MongoDB. and then these other lambdas are used to actually do authentication via the API gateway. And Cognito, when you register somebody, it automatically triggers and sets the confirmed users, so you don't have to do any type of manual confirmation yourself. So it's pretty straightforward. I think that Terraform would help out a lot in setting up a lot of your pieces, and it just be, you know, almost one-line command to set everything up. The deploy piece is, you know, for a small app, it's pretty straightforward to do it yourself, but you want to automate that using code deploy, some of the services that AWS has. I guess the other question is, you know, do I want to go serverless? For me, the consideration for that is, the one question I ask myself is, why do I need a Linux server to run any part of my app? Is any part of my app using any OS specific functionality, whether it's, you know, native API calls? Am I using their file system? Am I using inter-process communication? Am I using commands from that OS? And if the answer is no, right? If the only thing you're using is, hey, I've got a call from the client that says I need to get a list of things, and you're just talking to Mongo directly, and you're not doing anything that's OS specific, then this is, you know, I would probably start with Lambda Function API Gateway for your compute, your active components within your application. If you're doing mean stack, if you think about it, you've got Mongo Express, Angular, Node. The Express and Node part just provide serving up static files, which you can do with S3, and using this routing your domain name or subdomain name to S3. And then Express and Node also provide you with these RESTful services, which the API gateway can provide you, and the Lambda can provide, I guess the API gateway provides you the routing to your Lambda functions, to the appropriate code, and then your Lambda provides your active component or your reactive component that will give you the data, update data, delete data, etc. So none of this, you know, most applications don't use the services of an operating system. They're really just there to run processes, and not that much more in today's world. There are instances where you're going to use operating system or OS operating system specific services and functionality, but for the most part, in today's modular distributed systems and applications, it's really not there. So if I were to start a brand new app for a mobile phone or any type of functionality that requires saving data, getting data, initiating, you know, some type of activity, some type of action, I would definitely recommend starting with this type of structure where there's really no server that's running. You just got a bunch of AWS components that you're sort of hooking together and make sure that they play well together. So that's it. Hopefully you found this video helpful, and let me know in the comments what you think. Or if you have any questions, just leave it in the comments. Thank you.